Hello and welcome back to the Pony Math Teacher. Remember that we're using twice the video's length to take notes and wonder, pause the video, use the time to your advantage. I talk a lot, I talk fast, change the playback speed. It's all good, all right? It's there at the setting that's there for you. If I talk too slow for you, change it to 1.25. Then at least I still sound natural. If you change it to like 1.5 or 2, you're getting into the squeaky range. Not that I'm already a squeaky. But if you go slower, I will be sounding like I talk deeper as well. So just FYI. That it's okay. It's called sound waves, and it's fun. All right. Today we're doing two variable inequalities. So we've learned how to graph in slope-intercept form, and we've learned how to graph in standard form. Two variable inequalities just adds one extra step to either of those forms, so we know how to graph and shade in different locations for them. And you've already done one variable inequalities when you were graphing on a single number line. So we're taking all that information you already know and just sticking it together, and boom, you know something new, even though you already knew it. So, all right, comprehension questions are there. They are true or false questions that you'll have to justify. And in our current unit, we are now past standard form. We're past the halfway point. Two variable inequalities and page 31. Let's go. Let's go. Let's go. Let's go. And again, I forgot to get out the marker that I wanted to use. Ba-doop-ba-doop-bop. Ba-doop-ba-dop-bop. Let's do blue. We haven't done blue in a while. Actually, I think we did recently, but we'll do it again, because why not? All right, I'm going to write the 4 steps at the top in a flow chart. We're going to do 2 examples, so outline. It's really basic. Okay, so our first example will be our first step will be solve for y. This is typically what you'd want to do. Typically you want it in slope-intercept form, so that's what this is going to get you. One of our examples is in standard form, so you could do it in standard form as well. If you're doing it in standard form, then you can ignore these first 2 steps and just make them plot your x-intercept and plot your y-intercept, all right? Graph using slope and y-intercept. Now these 2 steps you do have to keep no matter what. Is it a solid or dashed line? Put commas in between there. Put that in the box. Bloop. And the last step, shade / test. Okay, so these are 4 steps. I do want to add in the fact that this is for y equals mx plus b. If it's in standard form, then just graph it like you normally. Basically, this first step just combines to graph it. So I will box this, because that's the goal. If you graph and plot your 2 points, okay? So we are going to do 2 examples. I'll do the first one in slope-intercept form, and then I'll do the standard form second. So we're going to have y is less than or equal to negative x plus 2. Then we'll have 2x minus 3y is less than 12. And I'm going to have a bunch of work at the top, and then have our graphs at the bottom. If you have a highlighter, this is a great lesson to use it on. Okay, so we have some blank space here, and I'm going to leave this as our viewing window. So for the steps, just look ahead on top of your paper and we'll be good. So we're going to solve for y. Boom, y, it's already by itself. It's in slope-intercept form. So we're going to graph using the slope and the y-intercept. So we know that our slope is going to be -1. It's the coefficient, the number in front of our x variable. And then I know my y-intercept will be at +2. So I'm going to go up 2 and go down 1, right 1. And I can go down 1, right 1 again to make this a better line. Now, this is where step 3 gets in. So we've just done the first 2 steps. Step 3 is to see if it's solid or dashed line. This is the same as doing an open circle or closed circle on our one linear inequality. So go back to that lesson and think about it. So an open circle meant there was no value there. A less than or greater than means there is no value there. So a dashed line will mean there is no value there. It is not an acceptable solution. It's not a viable solution. But if you include the equal to line or the equal to line, then it's going to be a viable solution. This exact line of y equals negative x plus 2 is a viable solution to this inequality. I could substitute in 0 and 2, have a 0 in for x, have a 2 in for y, 2 equals 2. Hey, look at that. It's true. So that means this is going to be able to have a solid line. And you want it all the way through the graph, okay? Especially for this lesson, all the way through the graph. So I have a solid line because this line is part of the solution. Now I know the line is or is not part of the solution, but for inequalities, there's way more solutions out there besides just the line. So I need to test those and see where they are. In order to test them, I have to find a point that's not on my line. So I could test negative 3, 1. I could test negative 3, negative 4. I could test any point that's not on the line. But the best point to test is going to be 0, 0. It's not on the line, and zeros make a lot of stuff disappear. So it's really awesome. So I'm going to test, and if I test 0, 0, that means instead of y, I'm going to replace it with a 0. I keep the same symbol. I keep the negative. Instead of x, I replace it with a 0. And I keep the positive 2. So all I'm doing is replacing the x and the y with zeros, because that's the x coordinate and that's the y coordinate that I'm testing. Negative 0, it's gone. Okay, now, is 0 less than or equal to 2? True or false? True. That means this point is a viable solution. Now, what's the fun thing about inequalities is if this point is a viable solution, this whole side is full of viable solutions. And since you have to be true or false, that also means above the line will be false. Now, to show a solution on a number line, we shaded. We did that little squiggle thing, right? So we're going to shade here as well. Woo. So if you have a highlighter, it's really fun. Okay, that is my final graph. I've shaded where it's true, and I've shown the line is also full of viable solutions. Okay, so that is slope-intercept form. It's really nice because having the y in this symbol right here, there's a pattern. So if you want to go online, practice some more, and see if you can figure out the pattern on your own. That's why slope-intercept form is awesome. But standard form is also really easy and really simple to graph if it's nice numbers. So this is an example with nice numbers, unlike the 5, 7, and 12 that I gave you last time. So on these, I'm skipping steps 1 and 2 because I'm just graphing it. I'm just finding the x-intercept, and I'm finding the y-intercept. So remember, x-intercept, y is 0, y-intercept, the x is 0. Okay, I'll dot my i's, why not? So if y is 0, cover up the line. 2x, imagine it says equals. Imagine it says equals. 2x equals 12. What is x? 6. Okay, x is 0. Cover it up. Imagine it says negative 3y equals 12. What is y? Negative 4. Okay, nice numbers. So much better than like 12 sevenths. Okay, so I'm going to go 6. 1, 2, 3, 4, 5, 6. I'm going to go negative 4. 1, 2, 3, 4. Now I have my 2 points, and I want to make sure I'm doing a solid or dashed line. This does not have an equal to line under it. That means this line, if I substitute in, if I did, for example, 2 times 6 minus 3 times 0 less than 12, I'd end up with 12 is less than 12. Is that true or false? False. That means that this is not a viable solution. This one's not a viable solution. None of the points on the line are viable solutions. So instead of doing a solid line, we do a dashed line. Which if you have a pencil, you can always just draw it and then erase a bunch if you want. If you drew it and then forgot about it and you're like, wait, it need to be dashed, just draw X's on it. That's what I do. I have a pen and I'm like, no, draw X's. So that's what I do. It's not a normal math thing. It's just, you drew it in a pen and I don't really want to give you a new piece of paper. So there you go. Now I need to test a point and see, is it this side that's true or is it this side that's true? And now I gotta test a point. What's a great point to test? 0, 0. And it's so much better with standard form because we've already done those 0 tricks, right? So if I'm going to test Test 0, 0. What's 2 times 0? 0. What's negative 3 times 0? 0. This is what I'm testing. Boom! It's already done. I didn't even have to like put it and then scribble it out. I just know that it's 0 is less than 12. True or false? True! That means this point will be true, so the whole side is true. What's this side then? False! And if it's true, then we get to shade where it's true. And we're done. Yeah. Alright. Do-do-do-do. Can you tell? Okay, there we go. These two statements, the 0, 0 statements there, they are true or false. Figure out which one they are. Justify your answer. They will be so helpful to make sure it makes sense in your brain. Have a great day. Thank you for watching.